how to find the derivative or sine inverse of x. So we let theta being the function of x, which is sine inverse of x. So if theta is the sine inverse of x, therefore x is just, we shift sine inverse and we say that x equals to what? Sine theta. I think we understand this concept, where when you are given such a function like x is given by sine theta, therefore getting theta, we are just shifting sine on the other side, so which it will be sine inverse of x. So wherever you are given such a function, then it is possible for you to take it back to this form. So I think now we understand how have I arrived to this step. Now let's find the derivative of this function. Let's differentiate this function in terms of theta now. Now it will be, when you differentiate x in terms of theta, it will be the derivative of x is 1. Then we have to multiply by dx d theta, since x is not theta, which it will be equal to the derivative of sine theta is just cos theta. I think there we are all together. Therefore the derivative of, so dx d theta, it will be just cos x. But remember that our function was in terms of x and our derivative is in terms of theta. Can't you see there? This is not what we are supposed to write it in that form. And also the original function was the derivative was supposed to be d theta over dx, since we were differentiating this function in terms of x. So the original function, the derivative of this function, sine inverse of x, it's supposed to be d theta all over dx. Can't you see here? This is not now the derivative of that function. So meaningly, getting d theta dx is just the inverse. The inverse of this function, it is the derivative of that function. Now let's take the derivative. So the not the derivative but the reciprocal of this function is the derivative of sine inverse. Now let's take the reciprocal of that function. So the reciprocal will be d theta all over dx. Also mathematically, whatever you do it in a one side, when there's an equal sign, you have to also do it in the other side, so that one, so as it can be mathematically correct, or you balance both sides. So balancing this side also, we have to take the reciprocal to be 1 over cos theta. Hey, so by now we have the derivative, but hey, we have to change a theta to be in terms of x. We were differentiating in terms of x. How comes here is theta? Now let me show you how we can come up with that value. Assuming our x was sine theta, so assuming we have this triangle, so that this one be our theta. So sine theta is just x over 1. So sine theta is opposite over hypotenuse. Therefore the adjacent should be square root of what? 1 squared minus x squared. Now this one is our adjacent. Now how can we get cos theta from this triangle? For we to turn it to be in terms of x, then you have to apply this principle. Therefore cos theta is just equals to what? Adjacent over hypotenuse, which equals to root 1 minus x squared all over 1. So we have our function being root of 1 minus x squared. Therefore, d theta over dx should be what? 1 over cos x, which is the square root of 1 minus x squared. This is our derivative for sine inverse of x. So for more, just like my channel, subscribe, and you'll get more about the differentiation calculus.